In our previous video, we took a look at how light acts off of a flat surface. Now we're going to take a look at what happens when light hits curved mirrors. The terms convex and concave mirror are really two sides of the same coin. So if we assume that our light is coming in from the left-hand side of our screen in this direction, we can then take our circle here and identify which part is the concave part and which part is the convex part. So the left side of our circle here, the side that bows outwards towards the light is our convex part. And then the part that is kind of caved in is our concave part. And we would assume that the light kind of goes in like this. So the part that is kind of bowed outwards towards the light is convex. And the part that is caved in relative to the light is concave. When light interacts with a concave mirror, it follows one of four very specific and predictable patterns. The first thing is we need to identify different parts of the mirror. So your concave mirror is going to be broken down into three different sections. The first part is the vertex, which is right where uh, the mirror meets what we're going to call the principal axis. The next point of kind of significance is the focus. And the last point is the center of curvature. You can think of the center of curvature as if this was a giant circle, that's where the center of the circle would be. And the focus is halfway between the center of curvature and the vertex. When light comes in, it's going to reflect off of the mirror, meaning it's going to bounce backwards, and it's going to follow typically one of four patterns. So the first pattern is that any light rays that are coming in and are parallel to the principal axis, so they're coming in the exact same direction as the principal axis, are going to hit the mirror and they're going to reflect through the point which we've denoted as F. So they're going to reflect through the focus like this. Our second rule is that any light that passes through C, the center of curvature, is going to reflect right back on itself. So we would draw just one line like that because the light is going to bounce off of the mirror and go exactly back on the same route that it took to come in. The third rule is any light that passes through F is going to come back parallel to the principal axis. So if it passes through F and hits the mirror, it's then going to come back parallel to the principal axis like this. And our last rule is that any light coming in and making contact at the vertex is going to be reflected out at the same angle at which it came in. So the angles inside V right here, this angle, the incident ray, and this angle, the reflected ray, um, as always, are exactly the same. The rules for our convex or diverging mirror are exactly the same, except everything is just kind of a little bit backwards. So the key here is that it's known as a diverging mirror, which means that the light that is being reflected out is all diverging in different paths. So the lines are actually never going to meet, unlike the previous example where the lines crossed. So we're going to start off by labeling our diagram first. Again, right here we have our vertex. We have F, our focus, and then twice that distance, we're going to have C, the center of curvature. And again, this part here is our principal axis. So the first rule is the same. Any light coming in, and again, we're going to draw our light coming in from the left-hand side of the screen. So light coming in parallel to the principal axis is going to hit the mirror. And what we have to do here is pretend as if it's going through the mirror first to see where it's going to come out. What I'm going to do is I'm going to draw a faint line that goes from our point through F, and I'm just going to actually fill it in as if it were a dotted line. So I'm just going to kind of fill in parts of it here so that we can see that this light behind the mirror isn't actually there. It's just kind of for us to be able to work with. So then we can follow that same pattern and take the light out this way following the same trajectory. So this is the direction at which the light will go. It's going to hit our mirror and it's going to bounce outwards that way on the same trajectory as F. Next up is if the light goes through C, and again, it's the exact same pattern as before. So if I were to draw this light pretending as if it was going to go through our center of curvature. So anything like this, for example, anything on the left-hand side is going to be a solid line because this light really is here and it is reflecting off of our mirror. And then anything kind of behind the mirror, we're going to draw with hash marks or dotted lines. Next up is light that looks like it's going through F. Now, obviously the light can't pass through F because it's behind the mirror. But if we draw a line like this, any light that looks as if though it's coming in this trajectory, so back here would all be hash marks or dotted lines, is going to pass and hit the mirror, and then what it's going to do is it is going to reflect out parallel to the principal axis, so kind of the exact opposite of rule number 1. And so the light would come out this way. The last rule is exactly the same as the previous slide, where any light that comes in towards V is just going to bounce right out the exact same angle as which it came in. And remember that we measure the angles. We're going to measure these angles off of the principal axis here. The purpose of these 4 rules for both the concave or converging mirror and the convex or diverging mirror is so that we can take that one step further and predict where images are going to appear based on the height location of an object, which we're going to see in our next lessons. Thanks for watching. Make sure you like, get subscribed, leave a comment below, and check out our suggested videos. Make sure you hit the bell icon so you don't miss any future updates.